So I found this website, Park Boards, and it has like boards of different thingies and stuff. Now, I do not know where I am. Okay, so here's the link I am in. You can come here if you want. Okay, just set it up. I will be doing some past papers obviously. Now, these are all a bit weird, and I cannot download them to put it over here. So you guys have to unfortunately look at me do them instead, or side paper. Let's read it. Okay, so what are the instructions? Oh my god. Okay, let's see. हर सवाल के सामने 4 डायरी. Dude, I cannot even read this. I'm so sorry. Please. do not kick me out of shower. Okay, this should be done in like 20 minutes. Expand cube. What? Oh, hell no. Okay, looking at the forms, these look pretty easy because a plus b cubed is equals to a cubed plus b cubed plus 3ab and a plus b, because it is 3a squared b plus 3ab squared. So we can group this to get this term instead. So this is how I think they are doing this. So 1 would be, if expansion of this, we get 2p cubed minus q cubed plus 3 times 2p negative q plus 2p minus q to get this term, and we get these two. Expansion of this, we get 8p cubed. Now 2 choices are wrong. Choice 2 and choice 4 are wrong. Let's look at the middle one. So we want to know, this is an minus sign over here. So we see that the first one is the correct option. Oh, it solved for me. Oh, I didn't even look at that. This is a bummer. Factorization of, so this is 8p cubed minus q cubed minus 6p cubed minus 2p minus q. Part 2. Factorization of 2lx plus 2mx plus 2nx is something. So 2 to 2. Everyone has a 2. Everyone has a x as well. So L M N. LMN. Yeah, nice. 2x LMN. If M and N are 2 polynomials and the HCF and LCM are respectively H and L, then M must be. Oh shit. If M and N are 2 polynomials and the HCF and LCM are respectively H and L, then M must be something. Let's break this down. M and N are 2 polynomials. Let's say they are 2 numbers. X and Y are 2 numbers, and their HCF and LCM respectively are L and M, are A and B. Now LCM of X and Y give us A. LCM of HCF, it gives us B. What does this tell us? X, so number A and number Y. Now, so X must have A, and X must be A and Y must be B. No. Okay, now these two are two numbers, but B and A do share factors together. However, they are made of some similar thingy. A can be expressed as A cubed, and this is A and this is B. Why does this one win? Because X has some AB where it's the biggest. X is a factor of, example, PQR, and Y is a factor of PQ and R. But X might have a bigger number of PQs R and then Y. So A must be the highest terms, P cubed Q square R square, and B must be PQR, the lowest powers. This is how we make sense of it. Obviously, we can have any number of primes. Okay, and HCF and LCM. Now, we can do some bullshit here, where if we see A is almost A, X is almost A, so we say A over Q is X and Y is almost this, so we can do BQ. We can now have this identity. LCM of X and Y is A and X and Y is B. They do work out, but they have this form. Now we need to ask ourselves, what is M? HLN? To be honest, I don't even know how this works, because in O levels you are taught by doing something. H and L multiplied? Oh, this uses that thingy where the multiplication of HCF and LCM gives us something. Gives us something, some damn thing. If we multiply A and B, we get P to the 4th, Q square, Q cubed and R cubed. Right. If we have AB, this is AB, right? And AB over Y, let's see. AB over Y. What is Y again? It is PQ squared R. What is A again? It is P cubed QR squared. Now over Y, so divided by Y we get P to the 4th, P to the 3, Q and R squared. Voila! What do you look at that? We found A. So we have this relationship AB is equals to XY. We can prove this by seeing X is equals to A over Q, B is equals to Y Q. Solving for Q, what do we get? Q is equals to B over Y, and X is equals to Q is equals to A over X. B over Y is equals to A over X, and hence we prove that AB is equals to XY. So we kind of use this rule, I guess. I'm not entirely sure. I invented this just on the spot. Literally, I never learned this. This is raw recording here, guys. Raw recording. You are seeing me derive this thingy. I got the even despite everything, I can do this. Okay, we used like half of our time here. Solution of the linear equation 2t minus 3t 2t minus 3 is equals to t minus 1 is minus t dynasty plus 3 t is equals to 2, right? Yeah, 2t is equals to 2. So 4 is done. 5 if u is okay, how many are there? 14 15 it seems. Okay, way back behind. 14 and 15 5 is if u is equals to 4 5 and v is equals to 7 6, of which of the given ordered pair is u times v? Multiplication? Excuse me, son? 4 okay, I do not even get this. Why do you even multiply this? Okay, p to the 9 can be expressed in radical form as root 9 p square, root 9 p square. Yeah, see, 6 7. If z is equals to this complex number, then its conjugate is 3i plus 13. Yeah, of course. Why is there imaginary numbers in here? Can be written in standard form as negative means to the left. So it is 0.00962. Which of the given is the base of common logarithm? No, I disagree with this. E. We all love E. If you do not love E, get out of my video. We all love E. Why not him? Come on, man. What if the given is a polynomial? What is this? 10.645? Given polynomial. What do you mean? Why is this the correct answer? Okay, because ascending powers. There's no negative powers. Whatever given represents one column of the matrix. Column. So it is that vertical thingy, you know. 6 negative 5 7, like the middle. In the here it is the middle row. Yeah. Which of the given two matrices are equal? Evaluating R, we get 10 and 9. S, we get 11 and 7. Okay, Q and S. Nice. If 13 is equals to A is equals to 2 3 6 4, then A to the who? T. A to the T. I think it's like a function. I don't know. Like it flips it on this side. If P is equals to and Q is equals to, P minus Q is equals to 1 minus 2 is negative 1. 1 minus negative 1. So this is two possible solutions. 3 minus 1 is 4. Okay, shit. 4 minus 6 is negative 2. Oh, damn. 5 minus 18 is equals to negative 8. Yeah, good. Nice. What? Dude, these two are the same. Excuse me, sir. The rational number 2/3 can be expressed as repeating sixes. Nice. And under 20 minutes. I wish I went this in detail. But yeah, this is like obvious. You know, I want to give this a try. 4, 5, v is equals to 7, 6. What? This is so weird. Yes, higher level mathematics. But this is class 9, code class 9. How on earth is this? To be honest, I'm not even going to ask. I look into this later. You know, I got bigger fishes to fry. Let's get the second paper going. View. Fresh or reappear is 40 minutes and 46 marks. Oh. Section 1, Section B and Section C. Let's do these. Determine whether G and H is equals to G or H or not. You cannot just assume. It's honestly, it can be like a special combination, because normally multiplication is very sensitive in matrices, so you have to do some goofy app to get your answer to it. Each part is 4 marks. Wow. Let's go. If G is equals to 17853 and H is equals to 8459, determine whether GH is equals to this thing. I do not have my calculator with me, so I cannot do this quickly. I'm so sorry, guys. Negative 6x squared y cubed, so this is negative 216x6y 9, and what do we have? 25a8 b7 b14. Nice. 3. Oohoo. Find a value of quote A. Why don't they even use like latex or something? I guess they, looking at this, they don't even have any money to even get like a better piece of thing. Okay, not saying that I'm not grateful. It is very good that they can at least show the math. Value of A in this. So log root 8 minus log root 8 3 is equals to log root 8 8. Oh, this is, where is A? Oh, this is here. A is here. Now, using log property, this is treated in like 1 and add, so this is 7 over 3 and log root 8 is equals to log root 8a. I don't think you need to show working, right? No. I still will, don't worry. We exponentiate both sides by the root of 8 and hence we solve for A in this instant. Evaluate the following and P is equals to negative 1. Dude, this is the most simple shit. Why is this 4 marks? 7 plus 6 plus 2 over negative 2 negative 5 is equals to 7 plus 6 is equals to 15 over negative 7 is equals to negative 15 over 7. Nice. UV, if U plus 13, UV, if U plus V is equals to 13 and U minus V is equals to 7. Are you threatening me with a good time? 2U is equals to 13 plus 7 is equals to 20. U is equals to 10. And hence, fourth V is equals to 3 immediately. So, UV is equals to what? Your mom. That immediately, like, this is so simple, guys. I hope I do not regret saying that. Let's first fix it up a bit. Yeah, I want some space to breathe. Without performing division, find a remainder when it's divided by p minus 3. Why? Why can I not divide? Dude, who isn't allowing me? Tell me. Why? Ain't nothing but a heartache. I want to fit means this? No, we cannot divide. This is 6. So why don't we divide? So what value is this going to eventually multiply 0 with? It is evaluating this function at the value of course. So it is 2p cubed plus 4p squared minus 7p plus 4. So this is 2p cubed, which is q times 2 cubed, which is 2 to the 4th plus 4 times 2 squared, which is 4, which is 16. This is also 16 minus 14 plus 4, which is 10. 32 plus 10 is equals to minus 10 is equals to 22. Yeah, that's so simple. Why? If we do sin dev, 2, 4, negative 7, 4, 2, sin dev is just like, to recheck. You guys can skip it. 4, 8, negative 16, which is some random ass value. 16, 17, 18, 19, 20, 23. Excuse me? What? I think I did this wrong. Like, no, I am wrong. This is 22. So this is 16. So this is 16, 10, 9, 9, 18. Yeah, 22. Nice. SINDEF is very easy, but it's very difficult, not allowing me. Simplify this expression. 2l, 3l minus 12 plus l squared minus 12 plus l squared minus 6l plus 18 plus 8. So we get this polynomial down here. Let's simplify this polynomial. So this is 8. 8 can be into 1, 8. Okay, negative 1, negative 8. Negative 2, negative 4. This gives us negative 6. So L can become L minus 2, L minus 6, L minus 4. Nice, in the denominator, and on the top you get L minus 2 on the top. L minus 2. So immediately we simplify this right equation. We get L over L minus 4 plus 2L over 3L minus 12 minus 12. This is L minus 4, 3 times L minus 4. So this is 2L, L minus 4 plus L, 3L, L minus 4 all over 3 L minus 4 squared. Now L minus 4s cancel out up here, so we get this normal. So this is 5L. Very interesting. They know what they are giving. They know what they are making us calculate. 8. Solve this expression. What? Square root of 2x minus 1 is equals to 10, 100, sorry, 2x, 90, 101, this is 50.5. Imagine using marks because you cannot divide. Imagine using marks because you cannot divide by 5. Very weird. So we need to plot this for, this is in terms of t, you idiot. For x is an integer, is a natural number. I do not even get this. How? Prove that the points are collinear. 10 collinear. How can you prove them that they are collinear? LM is equals to KMN. This is 4 marks, by the way. If they are parallel, then they are collinear. Yeah. So the gradient must be same. Let's go. So MN and ML, it is 8 minus, it is 2 minus 2 minus negative minus 3, 8. So at the top we get negative 10, at the bottom we get 2 plus 3, 5, so this is negative 2. This is for M of LM. Nice. And next we get MN. MN we have negative 8, negative 3, 8, 18. Nice. We get negative 16 all over negative 8, 9, 10, 11, 21. Excuse me? What? Oh no. Oh no. 3, negative 8. So sorry. 8, negative 3, negative 18. 8 minus 18, so this is negative 10, and this is also 5, which is what? M of M and N. Yes, eyebrow. To prove that if two angles and triangle are congruent, then the side opposite to those angles are also congruent. What is this random ass number doing here? Tell me. If two numbers are congruent, sides opposite to those angles are also congruent. How do you prove it? So, given a triangle, sides to those angles, opposite to those angles are also congruent. I mean, these are also congruent because the fact that this third angle is also congruent. Why do you to fool me? It's like a stupid question. Any point on the right bisector of a line. A right bisector. What? Of a line segment is equidistant from endpoints of the segment. You got to be joking me. You got to be joking me. It's a fucking isosceles. What? It share the same height and hence the same base, and hence by that assumption, for any given height and any given base, their hypothesis must also be same. Hence, they are equidistant. Section C. Any four questions. Okay, any four questions. Oh fuck. Prove that. These are all mensuration and shit. That's why people hate it. I don't know why. Prove that, prove that, prove that, prove that, prove that, prove that, prove that. I won't be doing question 8 because I cannot draw. Prove that if two opposite sides of the quadrilateral are congruent, then it is a parallelogram. How can sides be congruent? Okay, whatever you want, magic man. If given any two lines which are perpendicular and by that which are also same in length, then what? Then we can say for two parallel lines which are both the same length, connecting them must produce a parallelogram. From a point outside a line, the perpendicular is the shortest distance from a point to the line. Yes. That is true. Oh shit. Oh wait. Okay, sorry about that. I was like, looking at the WhatsApp messages someone sent me. Okay, perpendicular is the shortest distance because if we get any other distance from this point, we know that this is a squared plus b squared is equals to c squared. Let this be d squared and let this be h squared. We want to prove h is less than c. Fuck on man. C. Now taking the square root, I do not know what's the ruling of taking square roots. Let's look at this. Look at it this way. The graph of y is a square root of x. Y is the square root of x. It cannot go negative, right? So that's that. But h squared is not a proper function. If we plot h squared plus c squared, then minus c squared is equal to 0, then get something like this. Yeah, like this. Sorry, because there's like nothing thingy going on. Is equals to y squared. Now, if x was less than y squared, we would have this area filled. By that, x is less than the root of y, meaning this portion here. And we would also need to encapsulate this area as well, which is a chore. This does not have the same area. So we do this, which is the same area but flipped. It is the same set of inputs. So you can just take the positive root and call it a day, I guess. H is less than c squared. Why? Because solving for h, we know h squared is equals to root of c squared minus d squared. not know how to prove this. You know, because C can be just H plus delta H or something. But I think I'm sure there's a proof somewhere. Somewhere in the universe, somewhere someone got a proof. In 6 two sides of a triangle and same ratio, then it is parallel to the third side. Excuse me? Now the line segment intersects two sides of a triangle. Yeah. And it is parallel. Yeah, of course. So, assumption, let's get a vector graph going. Let's call this A and let's call this C. Okay, if we go from C backwards and into A, this is this side over here, A minus C. Now, A minus C is this line segment over here. If we were to go a part way up A, 2/3 A, we want to go 2/3 up A minus C. It is from A minus C is from going from C and back and into A. So this is CA. A minus C is CA. Like how AB is equals to B minus A. That's so different. If you want to go 2/3 this area, if you want to go like to a line here, then what do? We do C plus 2/3 A minus C. What do you get? C minus 2/3 plus 2/3 A, and this is 1/3 C plus 2/3 A. Very amazing. But there's a caveat, there's a slight issue. We have C over here, but this is a very lucky thing, because this component of C is perpendicular to C as well. It is just going this way, going the same way as we would like so. So we can prove that yes, they are parallel. It is parallel to this. The square root of the hypotenuse is equal to the squares of the lengths of the other two sides. Let's prove this. So we know a squared plus b squared, a squared plus b whole squared is equals to a squared plus b squared minus 2 plus 2ab. Now a plus b squared, what is that? That is this line segment over here, a squared b squared. Now this is ab, 2ab. In a triangle we have c squared like so, a plus b. If we have this triangle, the triangle's area is what? AB, half AB. How do we encode c squared inside here? We want to prove that removing these two blocks from this entire square gets us c squared. C squared is equals to a plus b whole square minus 2ab. We have the triangles A and B, and if we want to remove them from here, we hence remove this block. So we need to sum this area. We want to a plus b squared is this entire block. If we like this don't have it. Now minus 2ab. If we subtract these two blocks, we can subtract what? Instead we can subtract these squares. Like so. Every length is c. So this square is c squared. This square is what? Our c squared. And hence we can prove that we put a over here, a over here, a over here, a squared, b over here, and c squared also here. And this diagram, then we prove that, hence this is that. Nice. We have got all questions, I guess. I hope we get full marks or something. If you are a teacher teaching metric and see this video of a O-level student bullshitting their way to this, then I hope you liked this video. The thing is that it's really hot in here, so that's why the background noise is like all the mess. Okay, I hope you guys can forgive me. And make sure to like, subscribe and share. If you want a part 2 of this, if you want me to do class 10, then 100% I can do that for you guys. Okay, just tell me in the comments. Anyways, goodbye.